Hi guys, welcome to another Design Spark interview. Today we're going to be talking to Remap to understand a little bit more about what they do. With me I've got Pete Wood from Design Spark, myself Greg, and three gentlemen from Remap. Hi guys, would you like to introduce yourselves please?
Hi, my name's Rupert, or Ru as people call me. I'm a volunteer for Remap. I'm a professional engineer, if you like, but I dedicate my spare time to Remap to develop things to help people. And principally, I specialize in products which are mostly electronics based, with some programming as well. But I can do mechanical stuff as well.
Cool. Hi there, my name's Simon Merritt. I left the army a couple of years ago. I'm a professional engineer as well. I volunteered for Remap and I make anything mechanical or electronic.
Hi, my name's Peter Cattermole. I joined Remap a few years ago as a retired engineer. I was a civil and structural engineer, so most of the stuff that I make tends to stand still, but I'm now the chair of the trustee board as well.
Great stuff. So you guys are all engineers, which is great. But could you give us just a little bit of a history about what Remap is and what its aims are?
Yeah, sure. Yeah, Greg. Remap is a charity that serves people with disabilities of any age. So we've done projects for babies all the way up to the very old and everything in between. Our specialty is that we custom design and make and install equipment for the people for their particular needs. I guess what you could say is that we treat every individual as an individual, and their challenges they've got we treat as an individual design challenge. We come up with the solutions and we do them for free at the point of delivery.
Okay. And in terms of the people who are involved with Remap, what type of people are within your organization? Because you guys are engineers, is it all engineers?
No, you've already gathered that we've got three engineers from different backgrounds just on this call. But over and above that, we actually have volunteers of all sorts. We've got people who are acting in more administrative roles, who act as chairs and secretaries of local branches. We have 63 branches around the country, soon to expand into Scotland and get even more. And we're hoping to expand into some of the areas we don't currently cover next year. But we also have, the finances looked after by typically ex-accountants who are treasurers. We'll have people doing publicity, people doing fundraising. Basically, if you've got an interest in volunteering to help Remap, we will find a role for you. We have engineers from all sorts of backgrounds, and also people who just refer to themselves as makers rather than engineers. They may not be professional engineers, but they're people who are really good with their hands. They've made things, they've made toys and gadgets maybe throughout their lives. They're really good at DIY, and we can find jobs and projects for those people to do, again, all over the country. If we've got anything much more specialised, then we tend to lean towards Ru and Simon to get involved.
Okay. When you were talking about your regional setup or your regional representation, do those people actually focus specifically on projects within their region, or is it spread about across the regions? What's the best fit in terms of capability?
One of the things we try and do is to get people involved in their local area. So typically an engineer or a maker who's working on a project won't have to go many miles in order to visit their service user or their client or their occupational therapist that maybe they're working through to help that individual person with the disability. So it might be 5-10 miles, sometimes a little bit further. This year, of course, has been a real oddity with the pandemic. And so we've learned to do all sorts of new skills, working more remotely, using more video conferencing instead of face-to-face, using the occupational therapists to do some of our measurements and some of our close contact with clients. But typically, if I have to drive for any of my projects more than about 15 miles, I'm probably thinking the wrong engineer was assigned to it.
Okay. Interesting you mentioned this year, particularly with the COVID pandemic. Now, what we've seen in Design Spark, and particularly within the engineering community, there's been a lot of engineers who have wanted to help with things like 3D printing PPE, or even things like how do we make portable ventilators, that type of thing. Yeah. So From your perspective, how is it that people can actually get involved with Remap? So if they're sitting at home and they have ideas, or they come across something which is needing to be designed, how do they actually get in contact with you guys and bring forward some ideas?
Well, we'd love people to volunteer and come and join us, and we can get them in touch with their local branch in their area. And as I said, we have a network across the country. All they have to do is to go to the website remap.org.uk and click on the volunteer button, and that will take them into the right area, and they'll be able to get in touch with the local chair of their branch. We also have another website called makeability.org.uk, which is a great showcase for a whole load of projects that people have worked on. And in fact, you don't even have to be a member of Remap in order to post some of your inspirational projects for people with disabilities onto that site. You just join up and we'll let you post your stuff.
Okay. But in terms of some of the projects that you've worked on, how is it that they've came about? Is it been people who are aware of Remap that have applied to you, or have you seen a need where you've maybe come across something in the press or similar?
It's a great question. People tend to contact us, which is the way that we like it. Quite often it'll be the occupational therapist who's working with the individual client. They know about us, they know the sort of service we can provide. It is, if not unique, it's certainly uncommon that you get this sort of individual need assessed and built for. But we have carers and parents and sons and daughters contacting us saying, my relative, my person I know has got this issue, and could you help? And the answer typically is yes. Even if we don't know quite how at the beginning, one of the things that I think all of our engineers would say, we never give up. We'll keep searching for a solution, and we'll make something. And if it takes 3 or 4 or 5 prototypes in order to crack the problem, then we'll do it.
Yeah.
So do you tend to have these projects, are they very bespoke to a single individual, or sometimes are those like, that's great and we can now roll that across a whole number of people, or are they very specific to one person?
One of the beauties of the websites that we've got is it shows off some of the things that people are doing all over the country. And we do sometimes get projects that come in where somebody will say, I saw this thing, I'd love one of those things for my mother, son, daughter, relative. But almost always it involves some change, some modification, some innovation, and sometimes the engineers just get smarter as they carry on through the sort of the prototyping. In fact, I've got one project that's just come in, which I'm about to have a go at, which was actually one that was done by another engineer in another region and was spotted online, and they've come back and said, I want one of those.
Yeah, I've had that.
Yeah.
So they could be then something that's kind of already commercially available, it's kind of hacked apart and kind of repurposed to make something, or you're building something literally from the ground up, using Raspberry Pis or bespoke PCBs that you make, or I guess it's a combination of both, is it?
We started off, I think, back in the 60s when the charity was originally created, where there was very, very little equipment available designed for people to overcome their disabilities or to give themselves the independence they wanted. And so our original engineers from Remap were designing things from scratch. We still do an awful lot of that, but in addition, we do some modifications, and you'll see on the website things which have been, walkers particularly get modified for people that need assistance. And that again can be from children up to the aged. We had one recently where there was a child that wanted to be able to play alongside its sibling in the water on the beach, and yet the walker had wheels on and was just sinking into the sand. And one of our engineers designed a system to fit specialized balloon wheels onto it so that they can actually roll the walker across the sand and into the sea.
Okay, so should we talk about some of the projects now then with Rue and Simon? And so Rue, I met you at the Maker Fair in Newcastle, you might remember, a few years back, right?
That's right.
Was it that long ago, right? So, yeah. And I remember, I'd never heard of Remap. I'd seen various things, obviously, where people were on the TV, various TV programs and stuff. But I was just wowed by some of the things you were doing. So how did you get into Remap? You're obviously an engineer by day. How did you kind of discover Remap, and what was your kind of inspiration behind helping people?
Well, I think the the history of that one really revolves around a BBC television series called The Big Life Fix. I don't know if you remember that, and Remac were quite involved in that, and in fact I ended up doing some work with The Big Life Fix as well as a result of joining Remap. But we watched that program, my wife and I watched that, and I thought it was fantastic, and I thought, wow, what it must be like to help people who whose lives are so difficult. And there was a young lad on there that had EB, which is a dreadful disorder and he was a photographer, and the guy on the program had developed this camera that he could use from his iPad, and I just thought that was just an amazing story. And at the end of the program, my wife said to me, you could do that. And I said, well, yeah, I suppose I could really. And at the time, I make things for friends and family and modify things for people all the time, because when they know that you're into electronics and computing, that's the sort of thing that you end up doing. And I thought, well, rather than doing it for people who are less than grateful and don't really need it, I'd investigate Remap, which when you went on the BBC website, it said with help from Remap, and I thought, well, I'll find out who this Remap mob are. So I contacted them, and one thing led to another, and ironically, I ended up helping the guy who had EB with this camera. The BBC had handed that product over to them, and after they designed it, and it had some problems, and they were unable to support it. So ironically, I ended up going to see him. And I fixed it all up and did some modifications for him, and I ended up making about 3 projects for him, not related to the original one. So it was quite ironic that that's the way that it panned out. But that's what got me into it, and it's just the most rewarding thing you can ever do with your spare time. To be honest, it's so fulfilling.
And I guess as well, I mean, you can do this relatively cheaply, right? I mean, you have to have things like 3D printers and stuff, but once you've got that in your kit bag.
Yeah, I mean, having a 3D printer makes prototyping ever so easy, and having a milling machine and a lathe also helps when you're making things as well. But you don't need them. A lot of the people that are in our group are just woodworkers, and they have hand tools, and they make some amazing things. A lot of the things that people require are just adaptations, and a lot of the things I do are based on absolutely off-the-shelf bits and pieces. I mean, sitting on my desk as we all have, Raspberry Pi, Zeros, that sort of thing are fantastic for building all sorts of things for people. I've just finished a project using a Pi Zero for an engineer. There was an engineer who builds go-kart engines. And he uses micrometers like this one here, the sort of thing for measuring fine tolerances. Well, the problem with these, of course, is that unless you can see, you can't read the numbers on there. Now, there are Braille ones of these, but I don't know if you've ever seen them. They're huge, great, cumbersome things. And this guy was getting very, very frustrated because he had a little measuring equipment as well. And so I went out there, and these things are available. This particular one doesn't have it, but there are ones out there, and I think RS in fact sell them, that have Bluetooth on them, and they're designed for industry, so you can input the figures into the quality control system or whatever. So I just used a Raspberry Pi Zero, which has got Bluetooth and all the other prerequisites on it, and I put a text-to-speech engine on there. And he's just got a very simple box, looks like a transistor radio, just battery-powered thing. He has it in his workshop. He switches it on, he gets his micrometer out, and when he presses the button, it reads out the measurement. So now he's gone from spending, it took him about a day to rebuild an engine because he couldn't see, the only way he could measure things like clearances with feeler gauges. So it was taking him, he used to have to build the whole engine and then use the feeler gauge to find out whether he'd got it together correctly, and then dismantle it all, change shims and file things and put it all back together and measure it again with a feeler gauge. Now he doesn't need to do that. He could measure the clearances of the components using his micrometer, and it speaks to him, and he can build an engine in about an hour now. So, it's really, really transformational for him. So that's the sort of thing. And that was just an off-the-shelf Raspberry Pi, some off-the-shelf batteries. In fact, all the bits came from RS, I think. But they could be from anywhere, I suppose. But it was off-the-shelf stuff, really.
I think there'll be a lot of people who are listening to this who will have the awareness to think, oh, actually, I remember when I was doing some DIY and I was using my tape measure and I made the wrong measurement and cut something, and when I came to fit it, it was completely wrong. So I think we've all been there.
Because you're reading the measure upside down or something, yeah.
Absolutely. So yeah.
Speaking measuring equipment, I think is the way forward.
I think you've tapped into a market there. Absolutely.
It's a shame they can't integrate the actual speech synthesis into the product itself, because having to have two things is a bit of a drawback. But he's now thinking about getting some calipers and some different micrometers, all of which are available with Bluetooth. They're relatively expensive, so he's on a budget like everybody, so he has to. But the actual the receiver and the speech thing and all the rest of it, we provided that free of charge to him. So that's something which is important, because like everybody, but not everyone's made of money. So
yeah. And there's another project, Roo, that you had I think was really cool, was the one with I think it was the Roo Vision with the young boy who loved football but couldn't see very well.
Well, that was one of the first projects I did for EMAP, and that's been an ongoing project. But that's a guy that has got very, very severe visual impairment. He's also in a wheelchair, just to compound problems. As he said, I've got more. You can have more than one disability. It's some people think if you're in a wheelchair, you can't be blind as well. But unfortunately, some people are very get the real short straw with things like that. But he's been going to see Liverpool Football Club play at home, all their home games since he was a kid, and but he can't really see the football, so he sits on the sideline and he absorbs the atmosphere, and he listens on the radio for a commentary, and then when he gets home, I met him because he wanted an adaptation for his wheelchair. Actually, it was a sort of mechanical project originally that I was talking to him about, and it transpired that he was mad on Liverpool. When he went to his flat, he had Liverpool signed photographs of Kenny Dalglish on the wall, and he always wears a Liverpool shirt, and I said, you're obviously quite keen, and he told me that he goes to the football, but he couldn't actually see the game, and it wasn't until he got home at the end of the day that he could watch the highlights on Match of the Day or whatever. And he literally sits, and I'm not joking, he sits with his nose on the screen. He's got a 42-inch screen, and he sits that close, and he can just about see it. So I said, well, how about if we give you a similar experience whilst you're at the game? So what we've developed, and this has taken a number of years to sort of perfect, but he's on about the Mark III now, I think. Yeah. He now wears a ski helmet, and built into it is a camera. The video processing is all done with a Raspberry Pi, and he has a VR visor that comes down, and it's got a very powerful telephoto lens on it, because one of the challenges at football matches that you're probably at least 100 meters from the play, even when you're in a privileged position in a wheelchair on the touch line, which you are, but the players can be a long way away from you, so you need quite a powerful lens. So I sort of have built this up over a number of years using a variety of off-the-shelf camera components and Raspberry Pis, as I say, and now what happens is that it's like watching it on a 42-inch screen, but he's got it in his head. It was interesting because he was quite funny at first. He said that the players kept running out of shot, and he thought, well, where have they all gone? And because he wasn't used to, he hasn't been able to see since he was a very small child, and consequently he's forgotten how to sort of follow the play with his head. So after he sort of relearned to move his head when the players ran, he had to sort of follow them. Now he's got the hang of it. It's a completely different experience for him now. It's transformed his experience at the game.
Wow,
that's amazing, absolutely amazing. It's absolutely priceless.
Yeah. So Simon, ex-military, and you're doing this. How did you get into EMAP? I mean, you're an engineer, are you, from in the forces, or?
Yeah, so I joined the Royal Engineers in my early 20s, and I came from a mechanical engineering degree background. The Royal Engineers do a lot of construction, demolition. They've got a lot of involvement in explosives, military diving, and all around general good fun. But I suppose one of the things that I felt was slightly lacking until later in my career was a real investment in me as an engineer, and Remap certainly provides an outlet for that when your day job might keep you a little bit more desk bound and sort of, let's say, PowerPoint focused rather than integrated design or code or whatever else, whatever other forms of engineering outlet you like. And I was working at MOD Abbey Wood, where they do a lot of procurement. And I don't quite know how I heard of Remap, but I should say I'm married to an occupational therapist, so maybe something seeped in.
Yeah.
And I went along and found all these, some of the retired engineers sort of being kept out of mischief. But you certainly don't have to be old at all to give your time. So in my early 30s, and this was a great place for me to start really sort of letting my inner engineer back out again. Since then I've left, and I've made engineering part of my my two businesses that I run. Moved across from mechanical and building services more to electronics and RF. But still enjoying the opportunities for creation across a broad spectrum of areas that Remap gives.
Okay, so what's your favourite project you've done so far? I guess you've done a few.
I have. I tend to kind of dip into things that can be quite long running. My first project took well over a year to finish, and it was the example that you had earlier where some people see something elsewhere and say, can I have one of those? This was the case that they had the Kent panel had put some quite powerful worm gear motors that had been used for driving electric scooters and wheelchairs. They just attached friction drives to bowling wheelchairs, and these are quite strange things. They've got very wide wheels so that they put minimum pressure on the special carpet that they have on indoor bowling rinks, I think they call them, but maybe I'm getting the terminology wrong. And they go around the country and have these competitions, all these indoor bowls clubs. And the Bristol club had seen a Kent player's adapted wheelchair and said, hey, can we have one of those? So they came to Bristol, and naturally those motors were not easy to find. You had to buy, I think we'd have had to buy enough for 10 wheelchair conversions, and that was in no one's budget. So I set about sort of taking the principles of it and adapting it to technologies that were going to be easier to access. So we ended up with geared down stepper motors. And I think we ended up pulling the budget down from, I think, about £2,000 materials bill to about 200 and something. Wow. So an order of magnitude cheaper to convert them. Now, you did need to know what you know. You did have to still do the work to assemble it, code it, etc. But that was also a bit of a fly-by-wire project where we needed to take joystick inputs and take. You may have seen on the powered buggies before, they've got the joysticks on the armrest.
Yeah.
Well, all that's got the electronics control algorithms in there to sort of take proportional readings from the analog joysticks or hall sensors in there and turn them into some kind of proportional motor output so that the user's got decent control rather than on forward, you know, it's got to ramp up acceleration, all that kind of stuff. And so we had to do all of that. And I then sort of posted a summary of that project online for the control side of it. And I was contacted by a professor at Imperial College London, who then took the control or sort of tank drive that you have to do to steer a wheelchair like this as a problem for his master's students. And they came up with a project to make an open source software package that you could then apply to pretty much any motor controller. So that's now published open source online as well. So if people are repeating it, they can have a really much better version of the control software than I produce.
And that's what's great about open source, isn't it? The fact that you can then share that and make use of somebody else can take it and improve it, or reuse it. It's just great. So okay, that's cool.
Absolutely.
Yeah, no, I mean, generally everything I produce, I publish the code and the designs and the 3D printing things. In fact, they're all on Design Spark as well. So the micrometer project, I just did it the other day, and that's up there now. So the slightly ropey Python program I wrote to make it all work is on there. But if anybody wants to download it and improve it and play with it, then they can do that.
Cool.
Yeah. We're not at Remap. We're not into doing this for commercial benefit. We're just to benefit people who are in need.
Yeah, which is fantastic.
And I think from the sentiment that you guys are expressing, the payback you get is much more than any of the commercial payback you could ever receive, to be honest. And Peter, one of the things that you mentioned earlier, which really kind of struck with me, is that you treat everybody as an individual. So it's not a case of engineers coming to get to the end solution, because maybe that might be the easy thing to do. It's actually, does that end solution, when you've got there, map the requirements for that individual? And to your point earlier, Ru, is that if it doesn't, you take it and modify it till it does. And that's what really comes through is the power of how you guys are using your design knowledge, your engineering knowledge, but also then going to check to see whether this actually meets the purpose for that individual. That's a really, really powerful story from Remap.
Yeah, I've got a project on at the moment, which is a really challenging situation for a lady not far from where I live. And she had some medical issues which resulted in her arms having a great deal of involuntary shake in them. And it's not just a sort of a hand shake, it's a whole limb shake. And she wants to be able to do all sorts of things, and these days we're very lucky to have a lot of voice control assistants that you're able to integrate with a lot of things. So for example, just something like turning the lights on, she's unable to do with normal smart switches like you'd get with a normal IKEA or Philips smart light bulb, because that she just isn't able to align with them. And so I said I'd try and make her a custom controller that she could then control things with. The voice option was out because unfortunately her speech abilities were affected by her medical problems as well. So it was still back down to her hands, but then working out how we could get around that problem. And so the example of the prototypes thing going on, that's a second prototype of using some levered switches, just these two-way momentary switches that then provide levers. They've been offset, and with a case around them, the idea was that she would be able to rest her hand against the side of the case and get in and use those to scroll up and down a menu system. Well, when this was taken by the occupational therapist to her during lockdown, she was unable to really get in there and use it, even though we'd done an earlier prototype, which was much rougher. It was a block of wood with one of those switches screwed to it, and the dowel just drilled out and poked on the end. So we really don't make things fancier than they need to be. And that then resulted in what I thought was a fairly done and dusted design by that point, because there'd been a lot of backwards and forwards with her through her husband, and had to redefine what that lever looked like and provide a much larger surface to engage with and a much wider entry area. So this is just a 3D printed prototype, but at that point it no longer fits the switch option you've got, because with this one you've got a minimum distance to get the leverage where she can produce the force to switch it, but now our pivot point is shifting further and further in, and we're starting to expand out the size of the overall device. So back to the drawing board for not just the mechanical now, but the electronic side of it. This little, I don't know if you can see the little hole there, that then ends up with a magnet popped in it, and it now pivots around and rotates over two Hall effect sensors, which are on the back of the circuit board. Well, they're not actually, they're on the front, so you can't see that. And now we've got this nice, very lightweight mechanism, but it's now much more compact.
Yeah.
So we have the whole device now to contain the batteries inside the enclosure, which before they'd have had to been a separate one. And so now she's able to scroll through a menu, and she can now then go and select items. And not only in the mechanical side, but we've also got to build in adaptations in the software side, because she will have an involuntary movement where a normal button press would register it. So we're building in software filters where buttons have to be held down for a certain amount of time, and then they'll light up, and then she can let go and know that it's going to then change the setting. But again, if she does this lots, it's by accident, it's not going to change it. She's also got a dog which knocks near her wheelchair. we had to deal with that anyway. But yeah, there's a lot of thinking about the person's lifestyle, not just their inability, so their disabilities, but maximizing the things they can do. And also there are just other lifestyle factors that you need to take into account with every single person.
Wow. Very cool.
I love the thought about the dog getting in the way. I had one project where a lady in a wheelchair couldn't open her front door because she couldn't get close enough to it. So we added a lever to the front door latch with a rope and a tennis ball, and we trained her dog to open the door for her.
Low tech, but very good.
Very low tech, yeah, not like these guys.
Well, that's the thing, isn't it? Just some of these things you're describing, low tech is good enough, isn't it? I mean, but what you've shown there, Simon, is obviously, and what Roo was talking about with his Roo Vision, they're quite sophisticated bits of kit, right? So, you know, they're very, very clever things, and you wouldn't be able to buy that off the shelf, right? This is what's so great about what you guys do. It's the fact that you can look at the requirements, look at the person, and actually refine it right down to their individual needs. And that's what's really cool about what you guys do.
Because we give all of our time free, we can keep on going until we've cracked the problem. Commercially, it wouldn't be feasible. Almost anything we do wouldn't be feasible.
The other great thing about the group is that well, like you pointed out, Pete, that some of the things that we develop are actually quite sophisticated, and they involve multiple disciplines. And we often work together. Simon and I, for instance, work together quite a lot on projects together, because there is always part of a project which you're never quite sure about, and so you know, we'll call each other up and say, well, how do you think we should do this? And quite often, you know, Simon will say, oh, well, I've done one of these before already, and here's a circuit you can use, and so that's great. And the more of that we can do in Remap, usually the better. And I think that television program, The Big Life Fix, was a good illustration of that. If you can actually get great minds together, then even more powerful things can be achieved. So that's something that you know, at Remap we try as much as possible to do. So we don't necessarily all work individually, although there is a lot of people doing that because they like to work that way. But a lot of us also like to engage with others in the group, in the different groups, to make the sum of the parts usually ends up being more powerful than the individual effort.
So from Design Spark's perspective, we're going to continue obviously highlighting some of the stories and the activities that you guys are involved in. And at the moment, we would love to make a call out to our engineers on Design Spark platform to go to Remap. If you have services that you can offer, if you want to get involved, make sure that you go to Remap and get involved. We'll continue to tell the story, and I'm pretty sure that we'll talk again quite soon. This has been, for me, a really great afternoon spent talking to you guys. We could go on for hours, basically, talking about the stories and what you've been up to. But I think from the perspective of what do you actually get out of it, the real reward is actually helping people. Using your knowledge and, you know, your abilities to help people is such a great thing to do. So I really want to thank you guys for joining us at Design Spark today and taking the time to tell your story and share some of your projects with us. So thanks from me.
Thank you guys. Yeah, brilliant.
Thank you.
Love what you guys do.
Thank you guys. Thanks, Greg.